Hello, ladies and gentlemen. My name is Mr. Dotson-Kelly, an Algebra 2 teacher from East Hartford High School. Today, I'm going to teach you guys how to solve rational functions. Before we begin, I'm going to give you guys a list of steps on how to do that. Whenever I solve rational functions, I always determine my lowest common denominator first. After I determine my lowest common denominator, I'm going to multiply the whole equation by the LCD. Fortunately, when you are multiplying by the lowest common denominator, you can cross-cancel on both sides of the equal sign. This is allowed because the lowest common denominator is made up of the denominators from the entire equation. So at certain locations, things will cancel out. After you are done canceling, you want to solve the resulting equation. Now you have two options when this happens. You will either be left with a linear function, which means that the highest degree term is x. It's going to be mx plus b is equal to a different mx plus b. Or you're going to have quadratic, which means that you're going to have some ax squared plus bx plus c will equal to, we'll say, dx squared plus ex plus f. And you'll have something written in that format. So it's either going to be looking like this or like that, and from here just depends on how you have it. If it is linear, move all the x terms to one side, move all the constants to the other side, and now you have a one-step equation. If it's quadratic, move all terms to one side, then factor if possible, or use the quadratic formula if it is unfactorable. Now let's see a couple examples. In this example, ladies and gentlemen, I'm going to show you what you have previously seen, which is basically something called cross multiplication. I'm not going to go through the steps of what I taught you just now, but I am going to show you guys the cross multiplication and why cross multiplication actually is multiplying by the lowest common denominator in this situation. So here, ladies and gentlemen, x divided by 5 is equal to 3 divided by 2, or x fifths is equal to 3 halves, depending on how you want to say it. Now, in middle school or elementary school, they probably showed you guys something called cross multiplication, which is you take the numerator of one and the denominator of the other and you multiply them together. So that's x times 2 is 2x. And you do the same thing with your 5 times 3. And you can only do this across an equal sign. 5 times 3 is 15. But why does this work? So I have x over 5 equals 3 over 2. The reason this works is because I am multiplying by the lowest common denominator. I am taking these two fractions and I'm multiplying by the LCD. With 5 and 2 as my two options, if I write out their multiples, that's 2, 4, 6, 8, 10, 12, ... And over here I have 5, 10, 15. The number that they have in common that's the lowest, my LCD, is 10. And so if I multiply both sides, and I'm going to go ahead and do this, I'm going to multiply both sides by 10 over 1. I'm going to multiply this side by 10 over 1. You'll note that by doing some cross canceling, the 2 and the 10, they cancel out. I'm left with, and look at that, I'm left with 3 times 5, which is 15. And on my left hand side, this and this cross cancel, I'm left with 1 and a 2. That's 2 times x is 2x. Notice that when I multiply by the LCD, I get the exact same result from cross multiplication. And cross multiplication works because of multiplying by the LCD. So from here, my final step would be divide by 2, making my coefficient 1, and I'm left with 1x equals 15 divided by 2 is either 15 halves, but many of you guys prefer decimals instead of fractions, so this would become instead 7.5, depending on how you want to look at it. So it's either 7.5 or 15 halves. I always prefer fractions. Example number 2, this is when we now start to see more complicated rational functions. So 3 divided by x plus 2 equals 4 divided by x minus 1. Now what I'm going to do here, ladies and gentlemen, is I'm going to find my lowest common denominator. So looking at my two denominators are x plus 2 and x minus 1. Now fortunately, these are already completely factored. So what are the factors of the denominators? And there is no factoring here. It's just x plus 2. And this one is x minus 1. And to find the lowest common denominator, all you have to do is multiply what they have in common times whatever's left over. In this case, the only thing they have in common is 1. So that's 1 times x plus 2 times x minus 1. So I multiply what they have in common with whatever's left over. And whatever's left over are these two terms right here. So that's this right here. So I'm going to multiply both sides by these numbers. So my right side is going to become x plus 2 times x minus 1. Notice I am multiplying the right hand side by my LCD. I'm going to do the same thing on the left. X plus 2 times x minus 1. I'm going to again multiply both sides by that. Notice what I started with. I started with this right here, and I am multiplying both sides by the LCD. For step number 2, I'm going to cross cancel where I can. I notice that this now has a numerator with an x minus 1, and I have a denominator with an x minus 1. And similar to previous videos where we learned how to cross cancel rational functions, you'll notice that the x minus 1 and this x minus 1 now cross cancel. Similarly, on the left-hand side, I have an x plus 2 and an x plus 2. This x plus 2 is in my numerator. My x plus 2 here is my denominator. So these now cancel each other out. What I'm left with is 3 times x minus 1 on the left-hand side. And on the right-hand side, I'm left with 4 times x plus 2. I now need to multiply out using the distributive property of 3x minus 3. And then over here, I use my distributive property as well. And that is now 4x plus 8. These are two linear expressions. When you have linear expressions, I can move all my x terms to one side, all my constants to the other side, and I can solve. To solve this, I'm going to move all my x terms to the right side, and what that means is that my left-hand side needs to have 0 x terms on the left-hand side. In order to have 0 x terms on the left-hand side, I need to subtract 3 x's. But if I subtract 3 x's from one side, I must maintain a balance, and so I have to subtract 3 x's from the other side as well. These subtract to 0, which gives me my 0x. Simultaneously, I might as well move all my constants to the other side. Since I moved my x's to the right, I'm going to move the 8 to the left. Again, in order to do this, I want this to be a plus 0. In order to make that plus 0, I have to subtract 8. So I'm going to subtract 8, so I have 0. And if I subtract 8 from one side, I need to subtract 8 from the other. I now do all of my adding and subtracting all at once. Negative 3 minus 8 is negative 11. 4x minus 3x is 1x. The equal sign stays where it's at. This right here is my final answer. X will equal negative 11. Just to make sure, looking back at my original problem, 3 over x plus 2 will equal 4 divided by x minus 1. Does negative 11 make either of my denominators 0? And the answer is no. Negative 11 plus 2 is equal to negative 9. Over here, negative 11 minus 1 is equal to negative 12. So this negative 11 makes neither of my denominators equal to 0. This is a viable answer. Now let's see one more example of solving rational functions. In my third example, I'm going to analyze something that requires a quadratic result that will give us two answers at the very end. So I'm going to start with my equation, which is going to be x plus 3 divided by x plus 1. This will equal 15 divided by x plus 7. Again, I want to find my lowest common denominator, so I want to find the factors of the denominators, which means I'm going to take my two denominators, x plus 1, and factor it. It's 1 times x plus 1. I'm going to take my x plus 7. I'm going to do the same thing. That's 1 times x plus 7. And then from here, ladies and gentlemen, I find my lowest common denominator is going to be what they have in common, in this case 1. What they have in common, in this case 1. So the LCD is going to be 1 times whatever's left over. They have these left over, and they're individual. They're not together. So x plus 1 times x plus 7, and that's what I have left over. So I'm going to multiply both sides of the equal sign. I'm going to multiply this whole equation, the left-hand side and the right-hand side, by my LCD. So my left-hand side is going to be these fractions times x plus 1 times x plus 7. Over here, I'm going to be left with x plus 1 times x plus 7. Again, this is my LCD that is being multiplied to both sides of the equal sign. Step number 2 is cross-cancel where possible. So again, for cross-canceling purposes, I have to have the exact same factor in the numerator and denominator. You'll note that my denominator and my numerator here both have x plus 7. They divide to 1. And over here, I have the same thing. My x plus 1 and my x plus 1 divide to 1. So my left-hand side is left with x plus 7 times x plus 3. This will equal 15 times x plus 1. When solving this, we need to multiply it completely out. Let's start by multiplying our right-hand side out because that's easier. So 15 times x is 15x. 15 times 1 is plus 15. The left-hand side is a binomial times a binomial. This is a process we haven't seen in a while. You need to multiply out. I prefer teaching the area model. So to multiply out the x plus 7 times x plus 3, and I'm going to use the area model to do that. I'm going to scoot this up so you can see it. So that's x plus 7 and x plus 3. X times x is x squared. I treat this just like a multiplication table where I have to take my numbers on the outside and multiply them to get each individual cell. So in order to get this cell right here, I look to the left and I look up, 3 and 7. So 3 times 7 is positive 21. To get this cell, same thing, x times 7 is 7x. And last but not least, this one right here is 3 times x, which is 3x. I combine my like terms, 7x and 3x. So this becomes x squared plus 10x plus 21. This right here was the result of multiplying these together. This 10x came from those two orange highlighters right there. According to my steps, I want to move all my terms to one side since I'm left with a quadratic. So that means I want to move everything to one side and make a 0 on the other. So I'm going to take this 15x and I'm going to subtract it from both sides. That's going to give me x squared minus 5x. And I might as well in the same step move this 15 as well. So minus 15, this will equal positive 6. A lot of students have a desire to just leave it alone because what they've noticed is that this adds to 0 and this adds to 0, so like, hey, I have nothing there. If I have nothing there, then I don't have to write anything. I'm done, right? But in mathematics, when we have an equation, the equation is always there. And if nothing is left over, if this is empty, that means that there is a number there. The only number that represents nothing is 0. And so we've subtracted to 0 on the right-hand side, leaving us with a quadratic on the left. This quadratic is factorable. Going back to our factoring rules, what multiplies to 6 but adds to negative 5? So looking at my factors for 6, I can have 1 times 6, I can have 2 times 3, I can have negative 1 times negative 6, and I can have negative 2 times negative 3. And we want to find the sum of negative 5. That's what we're looking for. We're looking for the sum of negative 5. 1 plus 6 is 7. 2 plus 3 is 5. Negative 1 plus negative 6 is negative 7. And negative 2 plus negative 3 is negative 5. So that is what I'm looking for. This being my factors, I'm going to rewrite that over here. X minus 2 times x minus 3. This is equal to 0. Since I have factored it, I can use my zero product property, my ZPP. So I end up with x minus 2 is equal to 0 or x minus 3 is equal to 0. And I can solve both of these. Plus 2 to both sides, x equals 2, plus 3 to both sides, x equals 3. So here are my two answers. Looking back at my original problem, x plus 3 over x plus 1 is equal to 15 over x plus 7. I'm now going to ask myself the question, do either of these two results give me a 0 in my denominator? And as a reminder, you can never have 0 in the denominator of a fraction. You are not allowed to divide by 0. It is undefined. 2 plus 1 is 3, 2 plus 7 is 9, so 2 checks out. For 3, 3 plus 1 is 4, 3 plus 7 is 10. Again, it checks out. So ladies and gentlemen, this would be my final answer. I would have two answers. X equals 2 and 3 would be my result for this rational function. Ladies and gentlemen, thank you for watching my video. Stay healthy, stay safe, and have a good day.